So 4.4 already did the other ones that were done in the book. Here's the prime factorization method 1 factor tree brought to you by the Wu-Tang Clan Method Man. Find the prime factorization of 24. Try starting off with the different factor pairs to see what works best. And the nearest birthday to today in class has chosen the color pink for the color notes. Now, here's what happens with this. Whenever you see these guys here, what that is, and it doesn't go anywhere, if something can't be factored out, it is what? Prime. Beautiful. It is prime. So this same number is going to be repeated in these spots. Okay? It's going to be repeated in these spots. And when you do your homework, I'm going to have you just stop at the top where this would be, and you would circle it. But don't circle it right now. That's how it's going to be. So 2 and what is 24? Sam? 12. Correct. Now this guy is just going to go along for the ride. So I'm going to go ahead and write that down right there. He's just along for the ride. He's done. That's prime. He's already out there. Then we have 12 times what? One of those two numbers, we want it to be prime. Lainey? 2 times 6. Very good. Now this 2 is prime. It's just going to come along for the ride. How do we factor out? Yes?
Actually, couldn't it also be 4 times 3 since 3 is prime?
Yes. And we're going to get to that, actually. You'll see it. Okay? Yep, you're seeing into the future. Yeah. Yep. Yep, 3 times 2. Or I'm going to do 2 times 3. So I'm going to write it down on this line. It says rewrite least to greatest. 2 times 2 times 2 times 3. It's already like that. My 2s are not too pretty today. 2 T-W-O-T-O-O. Now with this one, we've already used 2 as a prime number to factor out 24. To show the diversity of what we can do, what's another prime number that goes into 24? Lady? 3 and 8. So this 3 is prime, so it's just going to go along for the ride. What you got? Sydney, what do you have for 8? What can we factor that out of? And? 4. 2 and 4. That guy's come along for the ride, and I'm not going to insult your intelligence. Okay, so it's 3, 2, 2, 2. Then to rewrite them all least to greatest, 2, 2, 2, 3. Same thing as before. Whoa. Now we have 24 with less branches of our factor tree. Okay, what do you think we're going to do here? 4 times 6. I like it. 4 times 6. And also, Jace, to refer back to your question, whatever factorization we do with a non-prime number, if you do it correct, it'll always come out the same no matter what order you do or how much you take away. Because if we would have done 3 right here, no. That was the one you wanted. Get out of there. Thank you. If we would have done 3 right here, then the 3 would have carried down, and that would have been 4 here, 2 and 2, so it still would have been the same. Okay. So we use 4 and 6, you said? Help me out with this one, Dana. Look at that. Boom. Same thing again. 2, 2, 2, 3. No matter what method we do, we get the same result. Now I ask you, why did the third try work faster? Raven, what do you think? I'm sorry, can you speak up, please? Less factors, okay. And let's see, let's use mathematical terms. Max, what do you think? It was smaller. Okay, so what does that mean? This one only had 3 branches. Or this one had 4 branches, or 2 branches. The other one only had... So you're saying the tree was smaller on this one because of what, though, Sam? Actually, I'm going to cut you off because Harrison doesn't contribute too often as much as you do, okay? You help out a lot, Harrison. He picks and chooses. That's okay. There you go. Both numbers, and that's not hashtag #PashVS, are composite. Composite numbers are a composition of things. Okay? Think of composing. You're putting everything together. Compost. You're putting a whole bunch of stuff together to make healthy soil. It does smell really bad. Okay? If it's working, that is. Okay? Both numbers are composite. That will make your tree smaller. Now the box method. The box method, and it is like the cake method for greatest common factor, but apparently it's being called the box method now. Or the ladder method. Questions? I have 5 different conversations going right now, and there should only be one. Why? That's between myself and you guys, or just you asking me. Got it?
Yeah.
Okay. Sydney, yeah? Yeah. I should put a timestamp with this one and then send it to your parents and be like, hey, at this moment, Sydney got in trouble in class. And then, Sydney, sit down. Sydney, sit. Sydney, put the eraser down. I'm sorry. Just kidding, YouTube. She's sitting nicely with her pen in her hand. Okay. Now, evidence. Yeah. You don't have to do the box method, but we will be doing it this one because I want to show you both ways. Now, when I first realized how to do this, when I first started looking over stuff in the past, recently, I didn't really like this one, but it's really kind of grown on me today. This is the thing to keep in mind with the box method. Everything outside of the box is going to be a prime number. So, Cam, can you tell me a prime number that goes into 36?
13.
That's Cam. 13? That, okay. No. No. You're right. I'm wrong. What number by 12 becomes 36? 3. So I'm going to put 3 out. Yeah. So then I would have 12 here. Okay? Because 3 times 12 is 36. Okay? Don't write those arrows. You don't need the arrows. That's okay.
Too late.
I should have told you. All right. 3 times 12. Now, 12 times what is a prime number? 12 times, yeah. Or, sorry, what times 12? I'm jumping ahead of myself. This is horrible. Let's try that again. What prime number goes into 12, Lena? 2 goes into 12. It sure does. So, 12, is that a... Every time you get an answer right, you get a little base, four things base. Not yet. I want you to put 12 for now. Or 2. So now, yes. What do you got, Johanna? Go for it. Try it.
No, it wasn't about the
Okay. What can we put into there? What goes into 6 that's the prime number? 3. What else? What times 3 is 6? Yes. 2. Look, every single number outside of the box is a prime number. So we have put them in order 2, 2, 3, 3. Now, to do the other version, and also to keep this YouTube video short as possible so it can upload by the time that you guys will be home. So, yes, question, Sam? Okay, what do you want to put here? Prime number, not 3, that goes into 36. 2. Let's try it. 2 times what is 36? Cam? Yes, 18. Good. What prime number goes into 18, Jace? 3. 3 times 6 is 18. 2, 3. Same thing again. 2, 2, 3, 3. It will be the same, no matter what. No matter what, no matter how. Here and here. If you have the same number, if you do the box method or the ladder method, you will always come out to that. Okay? Yes, Abby. To tie in our homework from yesterday, you are 100% correct. However, the homework that we're doing tonight, it's going to want to be like this, okay? Is it? Yeah, this is the crash course short version of stuff that you guys may have first seen last year, but definitely 2 more. Okay, 2 quick questions. We've got to move along. Please, no more other conversations. Okay? Dana. I don't. That'd be difficult. I did see a rainbow on Saturday, but
You did?
we'll see.
Rain?
Thank you. 2:35 baseball players, go get your picture taken. That's your warning. Okay. Now this one here, is there any other factors that we can do? Yeah. Okay. In fact, there is not, because the only two that we have, we've already used. 3 and 2, just to show you that there's only 2 ways to do this number. So yep, you put like a no sign. Okay. Why did the third try? Why did the third try not work? It's because there are only 2 prime numbers in the factorization of 36. So there's only 2 methods of doing it. That's it. You could start to do maybe this section different than this section, because you could have done 2 and 9, but you still would have ended up with 2, 2, 3, 3. Okay, examples from homework. Now, I will tell you this much. 1, the number 1 is not prime and it is not composite. However, I'm speaking. Just listen. However, the number -1 is considered a prime number, because you have to be able to represent an integer when you factor it out. And integers are positive or negative. And I will demonstrate that with number 1 on the example problems. Where is that? There it is. First step I'm going to do is I'm going to pull out that -1. -1, 18. This is exam, so you know what to do. Then we have 18. Can we think of 2 composite numbers that we can go from there so we make this short as possible? Ooh, Dominique. 6 and 3, true. 3 is prime. Can you think of the 2 composite numbers? Yeah. Raven? 9 and 2?
No.
Okay. 2 is prime. So is there one? Can we do one? No, we're going to have to use one. Okay, that's something that I want you to consider. Also, knowing your math facts. Will help you make it quicker. So we just found, I'm going to do the first one that I heard, which is going to be 3 and 6. This becomes 2. This becomes 3. I'm going to circle the ones that I'm done because I want you to do that on the homework tonight. Circle your prime numbers, and then you have them in order. What? Get out of there. Come on. 2, 3, 3. That's how you'll be writing it out. Because the prime factorization, -1 times 2 is -2, times 3, -2 times 3 is -6, -6 times 3 is -18. So this equals -18. All right, now the really tough one. Yes, question about that? Question about that?
So, like, for number 10 on the homework,
Okay.
it says -64. Would you pull out -1 and then put the 64?
Okay, he's asking for the homework. Number 10. It is -64. Ladies, please. It is -64. Would you pull out the negative first? If you don't do it first, you still have to do it at some time because when you multiply the factors together, they have to equal.
But what would the negative be when you pulled it out? -6 or like -1?
It could be -6, but -6 will come out to be -1 and 6.
So it could be both.
You just pull. You've got to pull out the -1 no matter when you do it.
And so you put any number for the negative?
Well, you could do it. Let's cover this up for a second. Okay, let's cover that up for. No. Don't you do this. Don't you do this. This is a hard one. We're going to do this together. I'm trying to answer Jace's question. So if I did this and I did this, I could do this, but then this would come out to be this. So it still becomes -1, 2, 3, 3.
Oh, so like for that one,
Shh.
you put like the -64 and you did like -8 and then negative or regular 8. You could draw the two other lines and then it would be like -1 and then positive 8.
Yes, as long as you pull out the -1 integer, that factor, you will come up with the same ending spot.
Would it always come out as -1?
Yeah, it's always gonna be pulled out. Okay. Yes, they're leaving. That's fine. Okay. Let's do number 2, and you need to pay attention because it looks like I'm losing some of you because it's Friday, but we have 5 or 10 minutes left of class. Okay. With this is number 2. I'm off to the side because I need a lot more room than you do. We are trying to expand all these variables, all these integers, the product of the integers. We will get this, so when they multiply everything together, they have it. So essentially, we are going to have 3 things happen here. What is multiplied together to get y squared? Raven. Y times y. Great. You can't get any less than that. I'm going to circle those. What do you multiply together? What 2 things do you multiply together to get x cubed?
Would it be x and then x, wait, and then 2?
I heard you almost say it. Your mouth made the shape to say it. If I multiply y and y together and they become 2,
X and then a little 2.
do you mean x to the power of 2? X squared? Yes. Yes. Here's a prime. And just as we did with the y squared, what does x squared come out to? Yeah, Dominique? Yep. You guys are making this seem so easy. I love it. So the people you guys are the only ones who have gotten to do this nice and slow like this. Now, we have this simple guy, which is just 42. Can we think of two composite numbers for 42? No. No. But possibly if you think of a higher composite or a prime number, it might be shorter. Yeah, Owen, get it in on the action. That's not a very high prime number. Yeah. 6 times 7. So, your answer for this is you're going to go with the lowest known integers first, then higher, then variables. So it goes like this. 2 times 3 times 7 times x, 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 y, y. No, because then it goes right back to the form it was. Well, see? Now, these last two examples show how to do everything from this on the homework to this on the homework to the homework. Oh, I closed it out. To the homework itself. Yeah, I closed it out. Rats. You do have to finish the rest of the problems on the notes and your homework. Yes. Your homework is only 15 questions, though, and you may choose any form that you would like. You have 5 minutes to work before you go home. Thank you very much. Happy Friday.